Okay, nothing wrong with my calculation, just my brain. Okay, now, that is going to give us, that's not going to give us vertical because you got this component there, prime. Okay, so that's our R prime perpendicular, right? R double prime perpendicular, right? So how are we going to get the unit normal?
Divide it by its magnitude.
Divided by its magnitude. So I can dispose of that rather easily. The unit normal is R double prime perpendicular divided by the magnitude of R double prime perpendicular, right? And I'm not going to do that calculation because it's really easy. It's just going to be negative cosine Ti minus sine T J. Okay? Because the magnitude is 4. Right? And if I divide by 4, that's what I get. Okay, so it's a very easy calculation in this case. Now normally, these things will be a little uglier. Okay? But just running through the calculations with a simple example. Thus, your unit normal is T cross N. Okay?
Your binormal?
Yeah. Seems like I can't write that simple relationship down carefully. Your binormal. Your unit binormal, and generally we don't contemplate anything but a unit binormal, so usually when you talk about the binormal vector, you're talking about a unit vector. Is T cross N. Well, there's your T, there's your N, right? Okay, well, I'm not going to go through that. Would you use the determinant calculation, or would you use distributive law?
Determinant.
Because you don't want to use a distributive law, even though you should have on several of your homework, because it would have been a lot shorter. You just automatically go to the determinant, you lose track of the distributive law.
I like to do it one way. I know how to do it that way.
Once you know how to do it that way, do it the other way, or do it both ways.
There's
You
more
learn,
chance-
it's like the difference between having binocular vision and having monocular vision. You have depth perception if you understand what it really means.
You make less mistakes if you do it the same way every time.
I'm not worried about making mistakes. I'm not an engineer. This isn't an engineering class, this is a math class.
This is fun.
And also,
Goes against my morals.
you miss potential efficiencies if you just lock into one way of doing it. So you have to weigh your ability to come up with more efficient ways to do things, which can be very beneficial, against the necessity of getting it right, which is also essential. But they're two essentials. And if you can do both, you're a better engineer. Maybe you're a slower engineer, though, and maybe your employer thinks that isn't as good. You know, it's a judgment call, okay? The distributive law is so simple and straightforward that you really need to be able to use it, and I probably put it on a test. You use the distributive law and use the determinants and show me which is more efficient, okay? Whether that comes up on your randomized test or not, you can maybe hope it doesn't, but it's really easy, okay? Okay, well in this case, I might well use the determinant, but I can do the cross product, I think, in my head pretty easily, okay? Because there are only two components of this vector, right? So you know, you're going to do I dot I, or I cross I, which is 0. You're going to do I cross j. I cross j is k, so you're going to have negative cosine squared t times k, times 0.8, right? Negative 0.8 cosine squared times the k. Anything else going to give you a k? Well, yeah, j cross I is going to give you a k, right? It's going to give you a negative k. So that's going to give you a negative 0.8 sine squared. But you had a negative 0.8 cosine squared, so now you just got a 0.8 k. So now I know what the coefficient of k is, right? I can look at these expressions. Now, if I've got 3 components and they all have different expressions, they're not going to simplify. There's no point to that, okay? But instead of writing out the determinant, you know, you can train yourself to look at these things and kind of see what it's going to be. Not a bad thing to do. Bottom line is, if you can do it one way, that's pretty much okay, unless I happen to ask, which I might. I want you to have both tools. I want you to see it both ways. It can be beneficial. Okay? So anyhow, you do that, you get your binomial. And it has to be a unit vector, but you should check that it is. Because if it isn't, that means you messed something up in your calculations. If you do the cross product right and get something that isn't a unit vector, it means either this or this isn't a unit vector, which means you messed one of these up, or both. Okay? And, or it means you did your cross product wrong.